Okay, so for number one, you have f of x equals log base 2 of x, and they tell you that x equals 256. So you have to evaluate this. So what we're looking for, remember, is we're looking for 2 to what power equals 256. That's what this means right here. So the power of 2 that gives you 256 is 8. 2 to the 8th is 256. So the answer to this is 8. Number 2 is the same as number 1. We're looking for 9, the exponent that makes this equation true. So 9 to what power gives you 6,561, and the answer is 4. So this would be 4. 9 to the 4th power is 6,561. Alright, so for number 3 we're going to graph. So if you see here, I put the reference points. 1 over b negative 1, 1 0, and b 1. b is 3 in this case. And then the h is 2, so it's x plus 2. The a is 2 and the k is 1, so it's 2y plus 1. So now I'm going to transform the points. And so I get 2 plus 1/3 is 2 and 1/3. 2 times negative 1 is negative 2 plus 1 is negative 1. 1 plus 2 is 3. 2 times 0, 0 plus 1 is 1, and 3 plus 2 is 5. 2 times 1 is 2 plus 1 is 3. So these points here, the 3 points on the right, are the ones we're going to plot. Alright, so remember logs have vertical asymptotes, not horizontal. So the vertical asymptote is determined by h. So in this case it's 2. So x equals 2 becomes the vertical asymptote. Okay, now we're going to plot the points 2 and 1/3, negative 1. So approximately right there, 3, 1, and 5, 3, 1, 2, 3, right there. Connect the points, and there's your graph. Okay, so for number 3, the domain would be all x greater than 2. So you write it like this. The range is all reals, or all logarithmic functions. Remember, the range is all reals. Vertical asymptote is x equals 2. You have to write it as an equation. For the end behavior, so I wrote the initial setup for end behavior as x goes to infinity. So as it goes to the right, f of x goes positive infinity. And as x goes to 2 from the right, the graph is going down, so it goes to negative infinity. And this one has no y-intercept because it doesn't go through the y-axis. So for number 4, log base 5 of x plus 1 minus 1, h is negative 1 right here, k is negative 1, and a is 1. So then these are the transformations of the points. So 1/5 minus 1 is negative 4/5, and then negative 1 minus 1 is negative 2. 1 minus 1 is 0. 0 minus 1 is negative 1. 5 minus 1 is 4, and 1 minus 1 is 0. Okay. So for number 4, the points, the transform points are there. I drew the x and y axis. I'm going to first draw the vertical asymptote, so that goes at h, at the h value, which is negative 1, right here. And then now we're going to plot the points. So negative 4/5, negative 2, we would say about here. 0, negative 1, and 4, 0. So you have this graph. So the domain would be all numbers greater than negative 1, all x values greater than negative 1. The range is all reals. Vertical asymptote is x equals negative 1. And for end behaviors, as x gets bigger, f of x also gets bigger. And as x approaches negative 1 from the right, the graph goes down, so it's negative infinity. The y-intercept is 0, negative 1. Okay, on page 61, for the first couple, you're just going to convert the form from log to exponential. So for number 1, you're going to write the base is 6, the exponent is r, and it equals x. And that's the answer. For number 2, the base is 3/4. The exponent is, and I'll just put parentheses, 35y, and that equals 12x. Okay, for number 3 and 4, you're evaluating. So you're asking yourself 5 to what power equals 125? So 5 to the third. So this equals, I shouldn't put x, it just equals 3. For number 4, the same thing as number 3. It's going to be 3 to what power equals 729. And you can use your calculator until you get the value. And the value for this is going to be 6. 3 to the 6th power is 729. Okay, so for the points, you just input them into a calculator and you get what you see here. For the 1 over e minus 1, you get negative 0.6, and then negative 3 times negative 1 is 3, plus 2 is 5. And again, you do the same thing here. E is 2.718, so minus 1 is 1.7. And then negative 3 plus 2 is negative 1. So we're going to go ahead and plot the vertical asymptote first at x equals negative 1. And then the points, that's going to be about here, negative 0.65, 0, 2, and 1.7, negative 1. Equals something like this. So the domain is all x values greater than negative 1. The range is all reals. Vertical asymptote is x equals negative 1. Okay, so as for end behavior, as x goes to infinity, f of x goes to negative infinity because it's going down as you go to the right. And then as x goes to negative 1 from the right, the graph is going up. So we put positive infinity there. The y-intercept is 0, 2. So for the transformations, you do x minus 4 and 4y minus 3 because h is negative 4, and a is positive 4, and k is negative 3. So 1/10 is the same as 0.1. So 0.1 minus 4 is negative 3.9 right here. And then negative 4 minus 3 is negative 7. For this one, 1 minus 4 is negative 3. 0 minus 3 is negative 3. 10 minus 4 is 6. And 4 times 1 minus 3 is 1. So first off, I'm going to draw the vertical asymptote at x equals negative 4. Oops. Right here. And then the points are negative 3.9, negative 7. So about here. Negative 3, negative 3, 1, 2, 3. And 6, 1 right here. So something like that. And so now, so the domain is all x values greater than negative 4. The range is all reals. Vertical asymptote is x equals negative 4. For the end behaviors, as x gets bigger, f of x also gets bigger, y also gets bigger. And as x approaches negative 4 from the right, the graph is going down, so it goes to negative infinity. Now for the y-intercept, we replace the x with 0. So you're going to do f of 0 equals 4 log. So it's base 10, so you don't have to put the base of the 10 if you don't want. So 0 plus 4 is 4 minus 3. We're going to put this into a calculator, and we get negative 0.59 when you round it to 2 decimal places. Okay, so I know here it looks like it went on negative 1, but it's just that I should have curved it just a little bit more. Okay, so the answer would be 0, negative 0.59. Okay, so these two functions here are inverses of each other. And so graphs that are inverses of each other reflect over the line. So they both reflect It's an F, not a T. Over the line y equals x.